माझा आवाज ऐकू शकता का? Please write in the chat box. Okay, that's good. Hope you all are doing good today. Let me present my screen. Okay, now can you see my screen? Please write in the chat box. That's good. And you can hear my voice also, right? माझा आवाज सुद्धा ऐकू शकता. That's great. So let's start with our mathematics class. So last time we came till we were discussing about rational numbers and comparison between them. Rational numbers असतील तर त्यांचं comparison कसं करायचं आणि how to decide like which number is greater than other number. So आपण last time quickly बघितलेलं की कसं करायचं असतं. So just small revision. लास्ट टाइम आपण बघितलं की 2 रॅशनल नंबर्स असतील तर आपण कसं केलेलं, ज्याच्यामध्ये क्रॉस मल्टिप्लिकेशन केलेलं आपण. I will quickly go through that. Like if there are two numbers 3 by 5 and 6 by 10, then we will multiply this with this and 5 into 6, and we will compare between these three, like 3 into 10 and 5 into 6, right? Order is very important. In which order you are taking, like first 3, then you have to take 10. So 30 and this is 30. So we both are equal, right? So that this is the way we have learned about how to compare between two rational numbers. दोन रॅशनल नंबर मध्ये कसं कम्पेअर करायचं, कसं क्रॉस मल्टिप्लिकेशन करायचं, हे आपण लास्ट टाइम बघितलेलं आहे. So let's move to the next thing. I will just clear the screen. Okay, let's go to the next topic. So let's learn about decimal representation of rational numbers. So आतापर्यंत आपण बघितलं की फ्रॅक्शन मध्ये लिहिलेलं म्हणजे अपूर्णांक, मराठीत त्याला अपूर्णांक म्हणतात. तर we know that what we learned till now how to represent rational numbers are like, let me change the color. Okay, so 3 by 7 or 5 by 10, 5 by 11 or something like that. So we have learned that rational numbers can be written in this form, but it is not always convenient to write in this form. So we have to take the decimal representation of rational numbers. So let's see what is mean by decimal representation of rational numbers. If we use, I'm just reading the context here. If we use decimal fraction while dividing the numerator of rational number by a denominator, we get decimal representation of rational numbers. So what is it stating? That whenever there is a rational number and we divide numerator by denominator. So what does it mean? Like everyone, we know that suppose this is 3 by 7, then 3 is numerator, 7 is denominator, right? This is numerator. So whenever we divide, we will carry out the division. Then whatever the represented is in decimal number. So let's try this thing. So they have given like 7 by 4, right? So 7 divided by 4. So if we divide 7 divided by 4, so we know that how to do division. So I'm not going into the detail, but this division, if we carry it out, we will get the number 1.75. So this is the rational number. This is also rational number, but it is represented in terms of decimal. Okay, so see, after point there are two decimals. Okay, so in this case, and we have to divide till we get remainder 0. Sometimes it is not possible, but for this division we got the remainder as 0. तर आपण बघितलं की रॅशनल नंबर अपूर्णांकाच्या रूपात कसे लिहायचे वगैरे आतापर्यंत बघितलेलं आहे. आता आपण डेसिमल मध्ये कसे रिप्रेझेंट करायचं ते बघत आहोत इथे. तर न्यूमरेटर जी वरची संख्या आहे त्याला खालच्या संख्येने भागायचं असतं. सो 7 डिवाइड बाय 4 गोज टू 1.75. सो 1.75 ही डिजिटल रिप्रेझेंटेशन आहे कोणत्या पण रॅशनल नंबरचं. इथे आपण बघितलं की रिमाइंडर म्हणजे बाकी भागाकार केल्यानंतर जी बाकी राहते ती 0 आहे. आपण ह्याला पूर्णपणे भागू शकतो. सो इथेच आपलं डिव्हिजन एंड होतं. पण काही रॅशनल नंबर्स असतात ते कंटिन्यू सुद्धा होतात, आपण नंतर बघू. सो दिस इज द डिजिटल रिप्रेझेंटेशन ऑफ रॅशनल नंबर. लेट्स गो टू द नेक्स्ट line. Okay, such a decimal form of rational number is called terminating decimal form. Okay, why it is terminating? Because it is this process stopped. Terminate means stop. So whatever the division we were carrying out, म्हणजे आपण जो पण भागाकार करत होतो तो स्टॉप झालेला आहे, कारण का आपलं रिमाइंडर किंवा आपली बाकी ही 0 आलेली आहे. म्हणून ह्या प्रकारच्या रॅशनल नंबरना टर्मिनेटिंग डेसिमल फॉर्म म्हणतात. ओके, म्हणजे इथे आपण शेवटचं आपल्याला उत्तर मिळालेलं आहे. सो आता आपण वी नो दॅट एव्हरी रॅशनल नंबर कॅन बी रिटन इन नॉन टर्मिनेटिंग रिकरिंग डेसिमल फॉर्म ऑल्सो. म्हणजे काही असे रॅशनल नंबर्स असतात ते आपल्याला म्हणजे तेच उत्तर येत राहणार आणि आपल्याला बाकी सुद्धा सेम 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 येत राहणार. तर अशी सुद्धा काही रॅशनल नंबर्स आहेत, आपण बघू आता. तो ते नॉन टर्मिनेटिंग असतात, म्हणजे ते कधी संपतच नाही. त्यांचा भागाकार आपण करत गेलो तर तो जातच जाईल. म्हणजे आपण त्याचा भागाकार करतच राहू तरी आपली ती संख्या काही शेवटपर्यंत मिळणार नाही, बाकी 0 होणार नाही. सो ज्यांची पण बाकी 0 होणार नाही किंवा रिमाइंडर विल नॉट बी 0, देन इट इज कॉल्ड नॉन टर्मिनेटिंग. Okay, so let's see one example. 7 by 6, right? So we know that if we divide 7 divided by 6, so then what we will get 1.166666666, and 6 will keep continuing. 6 हे असंच येत राहील, पण आपल्याला कुठेही त्याची रिमाइंडर किंवा बाकी ही 0 येणार नाही. सो ह्याला आपण कशा प्रकारे रिप्रेझेंट करतो, 1.16 आणि 6च्या वर एक डॉट दिलाय बघा. सो हा डॉट रिप्रेझेंट करतो की 6 हा रिपीटेटिंग आहे. ओके, 6 कंटिन्युअसली तिथे रिपीट होत राहील जोपर्यंत म्हणजे इट्स कीप रिपीटेटिंग, वी विल नॉट गेट रिमाइंडर 0. सो दिस इज कॉल्ड डिजिटल रिप्रेझेंटेशन ऑफ rational numbers. And moreover, which is this form? This is non-terminating. Okay, so similarly we will if we carry out the division of 5 divided by 6. So if let's we will do one thing. We will try to carry out some division so that you will understand clearly. So we know that division, how to carry out, there are different ways, but whatever the way we have learned, I'm just following that. So this is a 7 and this is a 6. Okay, so we know that 6 ones are 6, and if we take it 1, okay, then point, if we take 6 ones are 6, then again remainder is 4, and if we take 4 again, then 6, 36, again 4, if we take 0, again 6. So we know that it will be continuing this 4, and we have to, and this number is also keep continuing. So there is no limit for such type of numbers, and these numbers are called non-terminating decimal form. Okay, so we have seen one example. Now there are different examples also, like 5 by 6. If we divide 5 by 6, there will be number 0.0.8 8 and these 3 will keep repeating. So instead of writing whole 3, and we do not know that means there is infinite numbers, right? We can't define. So we write one dot that 3 is repeating. Similarly, if there is a negative sign, it doesn't matter. Okay, so that's why they have mentioned here negative sign, negative 5 divided by 3. So negative 1.66666 and 6 keep continues. So what we are writing? So minus 1.6 and on the top of 6 we are putting one dot. 6 च्या वर आपण एक स्मॉल टिंब देतोय, त्याचा अर्थ की 6 हा रिपीटेटिंग आहे इथे. Okay. Similarly, we will go towards 22.7 and this is a very famous number. We know that. Sorry, this is the value of pi. So pi मध्ये आपण बघू शकतो की जर आपण ह्याचं डिव्हिजन केलं, so what will be the number? 3.142857, 142857. So here not only one digit, but there are number of digits like this 5 digits. तिथे 5 digits आहेत ते सारखे सारखे रिपीटेटिंग होत आहेत. ओके, आपण बघू शकतो की इथे 142857 हे 5 नंबर पुन्हा इथे रिपीट झाले आणि जर आपण कंटिन्यू केलं तर हे पुन्हा पुन्हा असेच रिपीट होत राहतील. सो इथे काय करतात, जर आपल्याला एकापेक्षा जास्त नंबर रिपीटिंग असतील, सो व्हॉट वी डू, we will put some bar on the top of that numbers, those 5 numbers, right? So on top of that we put one line that is called bar line, and this line represents that this 6 numbers, sorry, these 6 numbers are repeating, right? So these 6 numbers repeating, hence we have put one line on top of those numbers. Similarly, there may be something like 23 by 99. So what is the number? 0.23232323. So here 2 digits are repeating. So we will keep a line or bar on the top of these 2 numbers only. Okay, so these are the ways we have to represent the digital number. Either a small dot on the top of that, it represents that only single digit is repeating, or line, the line on the top of the digit, ज्या डिजिटच्या टॉपवर किंवा त्यांच्या वर जर लाईन असेल तर ते 2 किंवा 5 जितके पण नंबर असतील तर ते रिपीटेटिंग असतात, असं याचा अर्थ होतो. Let's go to the next stuff. Okay, so similarly, so what here they have written is terminating decimal form can be written as a non-terminating recurring decimal form. For example, so आतापर्यंत आपण बघितलं की टर्मिनेटिंग आणि नॉन टर्मिनेटिंग. सो टर्मिनेटिंग डेसिमल फॉर्म सुद्धा आपण नॉन टर्मिनेटिंग फॉर्म मध्ये लिहू शकतो. कसं तर बघूया. 7/4 आपल्याला माहिती आहे की 1.75 नंतर आपली रिमाइंडर 0 राहते. बट जर आपण जर मॅथमेटिकली रिप्रेझेंट करायचं असेल तर कसं करणार? 1.75 0 0 0 0 0 0. So 0 is repeating here. So we can say that 0 is repeating here. Hence we have put dot on the top of 0. म्हणून आपण 0च्या वर एक स्मॉल टिंब दिलेला आहे. पण जर बघितलं, जर 0 जर रिपीटेटिंग असेल, ओके, 0 जर रिपीटेटिंग असेल तर ती संख्या आपण टर्मिनेटिंग डेसिमल फॉर्मच मानली जायला पाहिजे. ओके, सो ओनली थिंग we are putting dot or dot on the top of 0. So it means that 0 is repeating, but according to our terminology or according to our definition, this is terminating decimal form. Okay, so this is terminating decimal form. So though 0 is repeating here, let's try to calculate some numbers. So let's try to calculate 9/14. So can you write in the chat box about 9/14? What will be the answer? Please carry out the division. And if it is repeating, just stop there. Okay, please type in the chat box 9/14. What will be the answer? So is it terminating or non-terminating? What do you say, guys? I'm looking for your answers. Can you write down the 9 by 14? What is the answer? It's terminating. Please write in decimal form, and please tell me that whether it is terminating or non-terminating also. Someone has written terminating. Please check. There are different answers. It should not be, but please try to get your calculation right. Sorry. So still people are writing some different answers. It's terminating or non-terminating. So whether these digits after these digits gets repeating or we could not get answers, you will come to know. But okay, so we will see the answer. I think okay. So people are still getting confused. So if we divide 9 divided by 14, so answers will be around, means if we just go through that, uh, 6, uh, 6, 4, 2, 8, 5. Okay, that's we can see like after 5 years or 6 maximum. Okay, 7. So after this also, means generally what I will suggest that go till 6 or 7 digits. In engineering or there like a lot of calculations are involved where what we do is still check till 6 or 7 digits, you know. So that's the general way of other why I'm telling that about 6. सो जनरली एक्सपिरियन्स आणि ह्या गोष्टीमुळे बघितलेलं आहे की जेव्हा जर तुम्ही इंजिनिअरिंगमध्ये गेलात किंवा जर तुम्ही बायोलॉजिकल कोणत्या पण फील्डमध्ये गेलात, जर तुम्हाला नंबर रिप्रेझेंट करायचे असतील तर जनरली 6 to 7 डिजिट्स is considered as after dot, right? After digital form. Sorry. So 6 to 7 digits are considered for real time applications. म्हणजे काय, जर बघा आपण ही जर संख्या आपण 22/7 जर बघितली तर ही एवढी मोठी संख्या आहे. तर एवढी मोठी संख्या जर आपण नेहमी आपल्या डेली लाईफमध्ये किंवा डेली कॅल्क्युलेशनमध्ये जर वापरत राहिलो, so it will be very difficult for us to get the answer. I know that it will be accurate, but how much accurate we should need. So there is trade off, right? तिथे काहीतरी गोष्टी असतात की आपण पूर्ण टाइम फक्त कॅल्क्युलेशन्स करत राहायचं नाहीये, आपल्याला उत्तर सुद्धा पाहिजे असतात. जर आपण रिअल टाइम मध्ये आपण ब्रिजचं लोड कॅल्क्युलेट करतोय किंवा समजा आपण बायोलॉजीमध्ये आहोत तर बायोलॉजीचे जे कीटक वगैरे असतात किंवा मायक्रोब्स असतात किंवा बॅक्टेरियाज असतात, त्यांचा जर स्पीड कॅल्क्युलेट करायचा असेल तर आपण असं म्हणजे एवढे डिजिट्स घेऊन आपण सारखं सारखं कॅल्क्युलेशन नाही करू शकत. सो आपल्याला कुठेतरी थांबवावं लागतं. Okay, so generally that is range is 6 or 7 digits. Okay, so generally 6 or 7 digits नंतर आपण बघायचं की whether it is terminating or non-terminating. Okay, so here we can see that it is non-terminating, right? Still we are getting the remainder, and we don't know that afterwards also it will keep repeating, and there is no repeating format also, so that's fine. It is, if it is not repeating, then also it's okay, but we will keep getting some random numbers. Okay, so this is the one way of non-terminating. Let's do another problem so that it will be more clear. So let's go for minus 103 divided by 5, and please write in the chat box about the digital format of this rational numbers, plus whether it is terminating or non-terminating. Please write in the chat box. Minus 103 divided by 5, whether it is terminating or non-terminating. I think this is more simple way. Its answer, someone has written minus 2.6. That's not correct. Please check your calculation. Another answers came as 20.6. That's right answer, but I think one has missed the negative sign. So yeah, we have to be very careful that there is a negative sign also. So it's minus 20.6. And terminating, minus 20.6. That's correct. So someone has asked the question that how can we come to know whether the number is recurring or non-recurring? So we have seen that, after 6 or 7 digit, you will come to know. Okay. So see here the pattern. So 142857, after 6, just go till 7 digits, right? And you see the 1 again. So it shows that, okay, there may be something. So again, try next digit. If it is not repeated here till 7 digit, then you should stop. It's not recurring, right? So till that's my suggestions to you. Till 7 or 8 digit, try to do calculations, and if you see the pattern, then only you can write it's recurring or non-recurring. Okay, and I told you that this is the fundamentals. They are showing you that there will be recurring and non-recurring stuff and all this stuff. But if you go to the real-time applications, there will be maximum 6 to 7 numbers they consider for the calculations. Okay, so till 7 digits, it's okay. Okay, you don't have to keep calculating till 10 or 20 digits. No. Okay, so the suggestion is here till 7 or 8 maximum, go till that division. Okay, carry out the division till 7th or 8th digit, and if you see the pattern, then you can write that it is repeating or recurring. Okay, if it is not, you do not see format, that's fine, but it is non-terminating, right? Always it is not possible that there will be recurring. Anyway, so what's the answer for this? I think still only 3 people have replied. uh, I need more class participation. It will give me an fair idea. मला fair idea मिळेल की तुम्ही किती interactive आणि तुम्हाला माहित पडतंय. So please write in the chat box. Only 4 people have answered. Okay. sorry. So if we divide this minus 103 divided by 5, so answer will be minus 20.6. Okay, so this we can see that it is terminating. Okay, so after 6 there is remainder 0, so it's terminating decimal form of the rational numbers. Okay, let's move to the next stuff, that is irrational number. So till now we have seen the rational number which can be written in the format of like a by b, right? A divided by b. But there are some irrational numbers. Those are not rational, right? So we will study those type of numbers. So in addition to the rational numbers, there are many more numbers on a line. Okay, I'm just reading out loud about this paragraph so that you will also note it down while I am reading. So, okay, in addition to rational numbers, there are many more numbers on a number line. They are not rational number. That is, they are irrational numbers. And root of 2 is such an irrational number. So what does it mean? So रॅशनल नंबर्स तर आपण बघितले, पण रॅशनल नंबर शिवाय सुद्धा काही नंबर्स असतात नंबर लाईनवर, जे आपण नंबर लाईन अगोदर बघितलेले. दे आर नॉट रॅशनल नंबर, ते रॅशनल नंबर नाही आहेत, मग त्यांना काय म्हणायचं असतं, irrational number. Okay, so these are called irrational numbers. So root of 2 means you might have seen all this stuff, but just I am giving you here. We will study in detail. We will deep dive about this root 2 and what is meant by that. So root 2 is irrational number. So the number which represented in this root format is called irrational number. So let's see. We learn how to show the number root 2 on a number line. So we have seen the number line which start from 0, 1. On right side if we go 0, 1, 2, 3. Right side ला आपण positive numbers असतात, आपण बघितलेलं आहे, right? So this is the our number line. ह्याच्यामध्ये आपण 0 राईट साईडला कसे पॉझिटिव्ह नंबर असतात आणि लेफ्ट साईडला नेगेटिव्ह नंबर असतात. Sorry. So this way we can write down the all numbers which we can we can show a lot of numbers on this number line, but there are some numbers which we can't represent like rational numbers, and they are not rational numbers, so it's called irrational numbers. So let's go one by one. So now they are showing that how to represent or how to show root of 2 on number line. Okay, so let's see how to represent or how to show. Okay, so we'll go one by one. How to show root of 2 on a number line. Okay, on a number line, the point A shows number 1. So we know that this is a number line, right? So this is 0 and this is 1, and here maybe somewhere 2, right? Okay, so if we want to show root 2, what do we do? So first take 0 we know, and A represents number 1. Okay, draw the line L perpendicular to, okay, draw the line L perpendicular to number line through point A. So point A मधून आपण एक लाईन काढायची, ती आहे L. Okay, ही perpendicular आहे A ला. Take a point P on a line L such that OA is equal to AP is equal to 1 unit. So what does it mean? OA आपल्याला माहिती आहे घ्यायची लेंथ किती आहे 1. तसंच AP हा पॉइंट असा घ्यायचा की ओ ए जेवढी पण युनिट लेंथ असेल तेवढीच आपण एपी करू. सो काय झालं इथे 1. Okay, so by Pythagoras sorry, draw segment OP. आपण segment हा draw केला OP. Okay, so OP, the triangle OAP is right angle triangle. So OAP is right angle triangle. So now we know the Pythagoras theorem that we have learned, right? OP square, right? This OP square is equal to OA square, OA square आणि plus AP square. So this is the AP square. So we know the distance between OA, right, and AP, that is 1. So OA आणि AP चं distance आपल्याला माहितीच आहे. So आपण ते just इथे put केली ती value. So what is the answer? 1 square plus 1 square is equal to 1 plus 1 is equal to 2, right? So OP square is equal to 2. And if we take root of on the both sides, then what is the answer? OP is equal to root 2, taking square roots on both sides. So we know that OP, the length of OP is root 2. So if we want to represent on the number line, what do? We just take this arc here. So I will just put it up so that now we know that draw an arc with a center O and radius OP. So we know that this is the center and this is the OP line. OP is root 2, root 2, or the distance between O and P is root 2. So what we are doing, we are taking the center as O and trying to draw arc from the, so what is the distance of OQ? So obviously distance OQ is root of 2, that is square root of 2. So similarly, this is O and Q. Distance between O and Q is root of 2. And if we mark similar distance, like between, if we take O and Q and mark it on the negative side, then it is called negative of root 2. So it's very, very important to understand here is this is negative of root 2. Okay, so why? So okay, so this is root 2. Okay, and r represents negative of root 2. Please be careful that these both the things are not same. So root of minus 2 is not this. Okay, this is something different. And please never come, please never see this number in, I think, in your syllabus till 10th. This is not mentioned, I feel, but this is something different, right? This is called complex number. Just I am giving you idea so that in future you will remember that, okay, this is a complex number. Okay, so complex number are nothing but negative, like square root of negative values. Okay, so these are the different study itself and it has value, but it's not in your syllabus. Please do not consider, or if you have some interest in mathematics and you are going further for any mathematics study or any engineering study, or most of the stuff where we need mathematics, this type of complex number you will see. Okay, but not now. What is important right now is 2 minus. Okay, this is not complex number, this is irrational number. So please be careful to use this negative sign. Okay, so this way we represent the negative of square root. So let's go to the next. So they have mentioned that we will prove that. Okay, we'll prove that root of 2 is irrational number in the next standard. So this is not this is out of syllabus or out of context right now, but how to show that root of 2 is irrational number, you will learn in next standard. Okay, so we will also see that decimal form of irrational number is non-terminating and non-recurring. Okay, so this is a very important thing. So whenever you carry out the decimal form, this irrational number, it will be always non-terminating and non-recurring. This is to be noted. Okay, so let's move to the next. So okay, we'll read out about this note. So in this previous standard, we'll have learned what that pi is not a rational number. It means it is irrational, right? So previous standard we have learned about this, that pi हा जो pi ची व्हॅल्यू आहे ही रॅशनल नाही आहे. मग रॅशनल नाही तर काय आहे, इररॅशनल आहे. सो इररॅशनल आहे. So for calculation purpose, generally 22 by 7 is irrational, right? Generally what we take 3.14. It's very close to pi value of pi. But 22 by 7 and 3.14 are rational numbers. Okay. So if we consider 22 by 7 only or 3.14, these are the rational numbers. These are different way to, means if we consider only these numbers, okay, but value of pi is something different. Its value is, if we I also do not remember, it's not on top of my head, but it will be like 3.14 and some non-recurring non-terminating number, right? So this value is uh, irrational number. But if we take 22 by 7, 22 by 7 or 3.14, these are the rational numbers. So why? Like pi is, means not why, but why means I know that there may be some confusion. Like 22 by 7 is rational number and 3.14 is rational number. Then why pi is not? So what we are doing, we know that value of pi is 3.14 and some non-recurring, non-terminating numbers. Okay, but in practical purpose, I told you, right, if we try to write it all this stuff and try to do all the calculation, it will be time consuming, and sometimes it may not give you right, means it may not necessary also in practical life. So what do we do for that purpose? So we approximate, right? So approximation is the one term always we choose, but approximation is such a tool that, or I can say that approximation ही अशी गोष्ट आहे ना, की जी म्हणजे दोन्ही साईडला जाऊ शकते. एक तर खूप चांगलं होऊ शकतं किंवा खूप वाईट होऊ शकतं. म्हणजे जर तुम्ही व्हॅल्यू व्यवस्थित घेतली, तुमचे कॅल्क्युलेशन खूपच चांगले होतील, व्यवस्थित होतील, आणि ब्रिज बांधलेले किंवा तुम्ही मशीन डिझाइन केलेली किंवा तुम्ही काहीतरी जी व्हॅक्सिन म्हणतात आता, जे लस वगैरे शोधतात करोनावर, जर ती तुम्ही अप्रॉक्सिमेट व्हॅल्यू जर बघितली, सर्व चांगल्या असतील, तर बरोबर आहे, इट्स व्हेरी गुड. बट समटाइम इट मे फेल ऑल्सो. Okay, so you have to be very very careful while approximating the results. So what do we do now? Like so pi is one value of like 3.14 and there are non-recurring non-terminating number. Instead of that, what we do, we will approximate. So how do I approximate? Either we will take pi as a 22 by 7 approximate, right? Or we take 3.14, so it becomes rational number, right? And it's very useful for us, right? So yeah, as मी आता तुम्हाला मेन्शनच केलंय, तर तुम्हाला सांगतो अप्रॉक्सिमेशन how does it work. सो आता तुम्हाला माहितच आहे की करोनाची वॅक्सिन आणि त्याच्यावर खूप सारे संशोधन चालू आहे. तर तुम्हाला माहितच असेल की संशोधनामध्ये आता काय करतायत, तर ती वॅक्सिन काही ग्रुप ऑफ माणसांना, म्हणजे सर्व वयोगटांना, जसं 10 ते 70 वर्ष, राईट, सर्व गटातल्या माणसांना इंजेक्शन देत आहेत आणि त्यांचा रिपोर्ट बघतायत की त्यांच्या काही परिणाम झाला का, त्यांच्यामध्ये अँटीबॉडीज जनरेट झाले का. तर आता अँटीबॉडी जनरेट होणार, ओके, बट तर सपोज त्यांनी एक व्हॅल्यू सांगितली की अँटीबॉडी 3.14 जनरेट झाली एका माणसामध्ये, दुसऱ्या माणसामध्ये 3.15 जनरेट झाली, राईट? So how do we approximate? So there are like not real number like 3.31437895 म्हणजे अशी नॉन रिकरिंग नॉन टर्मिनेटिंग नंबर असतील, but that we approximate. Okay, instead of that we will see, sorry, okay, so instead of that what we'll do, we will approximate. Okay, so 3.14 एवढे जनरेट झाले असतील तरी आपण त्यांना मानू की त्यांच्यामध्ये अँटीबॉडी जनरेट झालेला आहे. सो आता 3.14 नंबर कुठून येतात? हा त्यांचा अनुभव असतो. जेवढे पण सायंटिस्ट असतात किंवा जे पण त्याच्यावर संशोधन करतायत लोक, तर ते एका नंबरने येतात की अप्रॉक्सिमेट नंबर एवढं तरी पाहिजे तर आपण म्हणू शकतो की अँटीबॉडी झालेत की नाही झालेत. ओके, काही जणांमध्ये खूपच 1 असतील, काही जणांमध्ये 5 असतील, राईट? सो हाऊ डू वी अप्रॉक्सिमेट? So how do we approximate? So these are the terms, like we have to come up with some approximation. But असं नको व्हायला की आपण वनलाच म्हणजे वन झालं तरी सर्व चांगलं झालं असं जर आपण अप्रॉक्सिमेट केलं आणि उद्या वन असलेल्या माणसाला सुद्धा काही प्रॉब्लेम येऊ शकतो फ्युचरमध्ये. त्याला करोनाची लस दिली आणि त्याच्यामध्ये फक्त वनच जनरेट झाला अँटीबॉडी, पण उद्या त्याला प्रॉब्लेम येऊ शकतो, राईट? सो अप्रॉक्सिमेशन कसं करायचं, का करायचं, ह्याच्यावर खूप सारं मोठं संशोधन असतं. सो तसंच हे ओघाओघाने आता आलं म्हणून मी तुम्हाला एक्सप्लेन केलं. बट तसंच आहे की पायची व्हॅल्यू ही खूप नॉन रिकरिंग नॉन टर्मिनेटिंग आहे, 3.145678 बट वी अप्रॉक्सिमेट टू 22/7 or 3.14. Okay, so value of pi is irrational, but 22/7 or 3.14 is rational numbers. Okay, please keep note of this thing. Let's go to the next stuff. Yeah, some voice is getting low sometimes. I'm really sorry for that if you see some communication problem, but yeah, I'm trying to keep my mic close to my speaking mouth. But yeah, sometimes there is technological issues. Okay, so there is another question: are all prime number rooted irrational? Yes, that's the uh, thing, like all prime numbers, if you consider under root, are irrational. That is the definition of irrational numbers, that whatever under the square root, it's terminated, uh, it's termed as uh, irrational number. Okay, so let's go to the next thing. Okay, now what we will do, we will try to read it out. So we have learned that root of 2 is irrational number. Okay, note that numbers like 3 root 2, 7 plus root 2, 3 minus root 2, etc. are also irrational numbers. Okay, so please keep note that if there is one irrational number and if it is added or subtracted from that number, or it is multiplied or divided by that number, it's always called irrational numbers. Okay. Because so there is like why, so there is always, so always there is some there is some terminology or there is some definition. So always try to ask questions like why. So they have tried to answer this, like as we mentioned, आताच आपण मेन्शन केलं की जर इरेशनल नंबर कुठल्याही संख्येतून ऍड करा किंवा सबस्ट्रॅक्ट करा किंवा त्याला मल्टिप्लाय करा किंवा डिवाइड करा, it always gives irrational number. So why? So because if 3 into root 2 is rational, then 3 root 2 divided by 3 should also be rational number, which is not true, right? म्हणजे त्यांनी एक ओघाओघाने एक theory मान लिया है कि जब 3√2 is rational, and if we divide 3 divided by 3, and then it is also, it should be like 3 divided by 3, 3 will be cancelled, and then root 2 will be remaining, right? And root 2 should be rational, right? But it is not true. Root 2 is not rational, it is irrational. Sorry. So now what we learned from this stuff is like, to show rational numbers on a line, we have already learned that how to show the rational numbers and even irrational numbers also. So similarly, we can show that irrational numbers like root 3, root 5 on a number line. Okay, so we will do an exercise now. We know that we have just seen that, sorry, we have just seen that how to uh, mm, how to calculate the root 2 or all this stuff. So let's do an exercise. So now if I want to represent number root of 5, okay, very simple question, but I'm just trying to see that how we can think of. Okay, so this is a number line: 0, 1, 2, 3, something like that. Okay, so here if I want to take, like, I want to represent this root of 5 here, right? So what should I do? So what I will do, I will take 0 and 1, and from 1 I will draw one perpendicular line, right? So what you have to show me, what you have to tell me in chat box is, what is the number, like what is the length of this line? Okay, this I will mention as PQ. Okay, so what I have to write, right? What we have to show is root 5. So what should be the length of PQ? Can you write in the chat box? So from 0 to 1, from 1 I draw perpendicular line. So what is the length of PQ? Q is on 1. Okay, so PQ, what is the length of PQ? Can you write in the chat box? Yes, answers are coming. Some people are writing 1 unit, some 2 unit. Please write in the chat box that if I draw from 1, I draw a perpendicular line, and the distance between P and Q, what should be the distance between P and Q? Sorry. So this is 1, this is 1 unit, and what should be the distance of PQ? And I have to represent root of 5. So we know the Pythagoras theorem. We have seen how to represent square root of 2. Similarly, you have to come up with some answer here, right? It is similar stuff. What should be the PQ? Okay, I think still I feel it's a bit difficult to grasp about this square root and average stuff. So we know that this is 1, right? So, and if we want to represent this as a root of 5, so what we will do, 1 square we know because of this distance, 1 square we know, and PQ square, right, should be 5. Okay, so we know the 1, so 4 pq square. So pq will be 2. Okay, so pq will be 2. So if we take 0 to 1, and from 1 if we draw a perpendicular line, so pq should be 2. Then we will get the root of pi between 0, sorry, this is o and p will be the square root of phi. So okay, I think still there is, I will give you in different way. Okay, again we will sorry, we will try to write again square root of phi, but this time what I will do, I will try pose the questions in similar different way. So now instead of 1, if I draw the perpendicular line from the 2, right? Sorry for my drawing. It's a freehand drawing. Okay, so this is a perpendicular line. So now A, B, and C. So if AC should be a root phi, then what should be the distance of BC? Can you write it in the chat box? Now instead of 1, I try to do it from the 2. I draw one perpendicular line from the B, that is BC. So instead of 1, I went to 2. So what should be the distance between B and C? It's similar stuff. I'm putting question in different format only. Come on, students, please write down the answer. What should be the BC? Okay, some people, yeah, I think now you guys are you are following all the stuff like AB square plus BC square should be phi, right? So AB square, we know the 2 square plus BC square, we have to find out phi. So BC will be 5 minus 4 is equal to 1. Okay, now you got the answer that how to carry out this means how to represent the line, sorry, numbers like square root of phi or square root of any numbers. So now I will pose another question for you guys. So suppose now we have seen for root phi, we have represented two numbers, right? 2 and 1. Okay, so if we square it, 2 square 1 square is equal to phi, right? So there are two numbers. So we can write in different way, like we can go like on number line 0, 1, 2. Okay, so we can go from 0 to 1 and draw perpendicular line of 2. Okay, that's we have seen 1 or 2. Or there is another way, from 0 go to 2 and draw perpendicular line of 1. Okay, so both will give us answer same. Okay, so similarly, if I want to do the square root of 7, I know this is a bit difficult, but just let's try. So what should be the two numbers we should work on? Okay, I will give you a hint. Oh, no hint. There is no hint. So if we want to represent root of 7, I know it's something difficult, but yeah, always If there is difficulty, then only. Okay. I know this is a bit difficult for you guys. So instead of that, we will go for square root of 8. Okay. So if we want to do it for square root of 8, which two numbers we should consider on the line number, or what should be the unit, right? Can you write in the chat box? Now I have changed the number. So it's square root of 8. So if we want to represent on the number line, which two number we should take? It's it's simple. Okay. Someone writing 4. So okay, if we take 4, so you know the, oh sorry, square of 4 becomes 16, right? It's very difficult to uh, subtract from 16 to get square root of 8. It's always should be addition here. If we want to represent square root of 8 on the number line, please check that it should be always added. 6 and 4, again the 6 square goes as 36, so it's no way. So generally square this number for your convenience. So square of this number is 8. So square of anything should be less than 8. Please keep note of this. If you want to represent on the number line, then you have to square it 8. So 8 we can divide. So if we take 4, then the 16 we can't uh, subtract on the number line. So 8, so there is, the square numbers, right? 1, 1, what is the square of 1? 1. For 2, it is 4. For 3, it is 9. So we can't take 3, right? So we have to manage with 2. So if we take 2, 2 square is equal to 4. So 4 plus 4 is 8, right? So this is the way we should represent the number line. So if we want to calculate the root of 8 on number line, what we will do? 2 and 2. Okay, so show the number line 1, 2, 3, 4. So from 0, go to the 2. At 2, draw one perpendicular line of the same unit, 2. Okay, and this hypotenuse will be called as square root of 8. Okay, so this is all for today. If you have any question, please write in the chat box, or we will leave it today here only. And have a great evening and have a great day to all of you. Take care. Thank you. Please leave this meeting so that. Hello, please leave this meeting. Hello. Can you please leave this meeting? Hello.